While NASA's busy circling Mars and trying to plant a flag on the moon, China just fired a rocket at Earth's secret mini moon and basically said, "We'll take that." The Tianwen 2 launched 5 months ago, and it's already closing in on Kamo-Leva, aka Asteroid 2016 HO3, a 50-meter cosmic sidekick that's been orbiting Earth for centuries. And it isn't a flyby, it's a heist. China plans on bringing samples home by 2027. And if those rocks turn out to be lunar fragments, Beijing just scored the cheapest, closest moon material in history. The space gold rush isn't coming. It's already here. And China's holding the map. So, normal asteroids scream past Earth at 30 kilometers per second. Quasi-moons like Kamo-Leva, the newly discovered asteroids 2025 PN7 and 2022 RD2 drift along at relative cosmic walking speeds, sometimes closer than the moon, the actual moon, in terms of relative speeds. So what about delta V, or the energy to reach it measured in change in velocity to reach these quasi-moons? Spare change. Mission energy? Less than flying to the moon, it's the far side. And you can spare all the energy or fuel required to land and take off again. So then we have asteroid 2022 RD2, which may basically become a quasi-moon soon, and then crash. It has a risk of hitting Earth. By mining these, we can turn potential risk into much needed resources and brimming bank accounts instead of damage in our backyards and cities and homes, or worse. That's why China's picked one. And it's a decent size, offering a good amount of materials. Doesn't require a lot of energy to reach it, making it presently the lowest hanging fruit in the entire solar system. Now you can see why they're trying to grab this one, right? Anyway, so back in May 28th, 2025, a Long March 3B rocket roars off the launch pad at the Xichang Satellite Launch Center. On board, a 2-ton robotic bandit with two jobs. Job one, rendezvous with Kamo-Leva in 2026, scoop up regolith with a spring-loaded arm, and drop a return center capsule over the Gobi Desert, in 2027. Job two, slingshot away from Earth and cruise to an active comet by 2035. Too bad they're not on the way to 3i Atlas, right? Anyway, so the world calls it Kamo-Leva, the Hawaiian phrase for oscillating celestial object, or fragment, or wobbling object. China calls it the Ka-Mao-Lava. Ka-Mao-Lava. Yeah, these words are tough on my tongue. Anyway, just using Mandarin symbols to say the same thing. Every Chinese National Space Administration, CNSA, broadcast, state media update, and Jinhua headline stamps it in Mandarin. They keep the Hawaiian spirit, but claim the narrative. Every kid in China now knows exactly which space rock their country plans to grab first. What about the kids here in America? What? Never heard of it. Meanwhile, in America, NASA's largest asteroid return sample is Osiris Rex. That was the last one. It was a brilliant $1.2 billion project, though. It landed in 2023. The next U.S. asteroid milestone is Psyche. We got a probe named Psyche arriving at the asteroid Psyche in 2029, bringing back 0 samples. And that's just too bad considering we think there's a lot of gold on Psyche. China's TL-12, well, it launched in 2025. Samples land in 2027. Then it flies off and keeps flying for another decade on its way to an active comet and Lord knows what. That's just not faster. That's running laps. So, enter 2025 PN7, discovered in August of 2025. Already Earth's newest quasi-moon until 2083. Harvard astrophysicist Avi Loeb drops a bombshell theory. He claims it just entered orbit the same year as the Soviet Zond 1. Well, how about we discovered it rather than entered orbit, unless it was Soviet Zond 1. Anyway, he said the probe disappeared in 1964. So what he's meaning is that one of these quasi-moons might not be a real rock at all, but Cold War hardware circling us 60 years later. It could be the upper stage booster used to launch the Soviet Zond 1 probe toward Venus. Yet it could be a tiny asteroid. We just don't know. we are not even exactly sure how big it is. Somewhere between 14 and 36 kilometers is with the best guess being, 13 to 16 meters. With the best guess being 19 meters. I'm so used to saying kilometers when I'm talking about asteroids. These are much smaller. Anyway, if it is a typical asteroid, it may weigh around 5.4 to the 10 to the 9th or 1.26 times 10 to the 10th kilograms. Well, okay, let's put that in English. That's 11.88 billion to 27.72 billion pounds. Hey, in that case, it's a worthy target. And even if it is a upper stage, hey, already processed metal in space, one of these days ought to be worth something. We have a lot to learn here. So let's look at an asteroid near Earth that could become a temporary moon and then a crash rest. Yes. Then there's asteroid 2022 RD2. Yeah, too bad it's not R2D2, right? Scientists found a small asteroid that may circle Earth as a little moon before becoming a hazard later this century. An uncommon class of space rocks called Arjunus includes 2022 RD2. That's a lot of twos. These objects circle the sun like Earth, but sometimes wander near it at unusually low speeds relative to Earth. I mean, basically, they're in Earth orbit or very close to it. That slow pace can trap them in Earth's gravity for a brief time, creating small moons, quasi-moons of Earth, researchers say. That can make them a lot easier to mine, too, fortunately. NASA has computed the asteroid's orbit and placed it on its risk list for collisions. But its Center for Near-Earth Object Studies has different predictions. Okay, so there's more than one NASA, and different NASA centers sometimes look at things differently. These estimates suggest that 2022 RD2, I should just call it R2D2, could be one of these real Earth, near Earth rare asteroids to go from near Earth to temporary moon to a crash danger in less than a lifetime. You can see it. Maybe in your lifetime, unless you're an old guy like me. I plan to live for a long time, so yeah, I might see it too. But anyway, some minor objects near Earth are old spacecraft or rocket boosters. as Avi Loeb suggested. Uh, but it's thought that 2022 or D2 is likely natural. At least that's what the researchers are saying. Their projections don't rule out a future collision, but they can't confirm it. This one is smaller, maybe just 3 to 15 meters, and not kilometers. 3 to 15 meters. But the consensus is that's probably around 9. Yet, even at 9 meters, it could offer 2.2 million pounds of useful materials in space, which could be worth actually many billions of dollars. You see, there is a reason to go for these instead of having them smack us. See, would it not be far better to turn it into solar panels, wires, or building materials, or orbital foxholes for protecting satellites rather than take the risk of it hitting us? Of course, this smaller body could cause a Chelyabinsk class blast. But if you remember in Russia when this occurred, it injured almost 1,500 people. Or, if we're lucky, it might just burn up in the atmosphere. That's what we'd hope. Even if the latter, and it were that case, it would be a colossal waste of potential precious resources. How too bad. We should be grabbing these things, not letting them just burn up. The Uranus asteroids offer a lot of low-hanging, ripe, rocky fruits awaiting just for the taking. So let's go get some. But we have some other close asteroids to us. We have just recently discovered 2 asteroids, both in the Sun-Earth Lagrange point 4, which is in Earth's orbit around the Sun. Actually, it leads Earth in its orbit around the Sun by 60 degrees, to be more precise. That's where Lagrange point 4 is. These asteroids, 2010 TK7, which has a diameter of about 300 meters or 1,000 feet, and 2020 XL5, which has a diameter of about 1.2 kilometers or 3/4 of a mile. Now we're back to kilometers, right? That's a big rock. It is the second Earth Trojan discovered after 2010 TK7. So we actually found the smaller one first. Just suggests there may be more to find, right? If either of these hit Earth, it would be catastrophic. We're going to go into some of these impact levels at different size classes in just a few minutes. However, given that they are in Earth's orbit around the Sun, the delta V and energy to get to them should be low. Each is large enough to have a treasure trove of materials. Let's hope China doesn't sneak more launches to beat us to these 2. The good thing is there are probably a lot more asteroids in these Sun-Earth Lagrange point systems, or at least we hope, especially in the smaller class. A lot more things that we could work with. But now let's think, how many of these have we found? Well, as of November 2025, humanity has cataloged 40,000 near-Earth asteroids. We're not talking main belt. Near-Earth asteroids. 40,000, with 10,000 being found in just the last 3 years. Next year, the Vera Rubin Observatory switches on, and it will add another 10,000 annually. Now, that's good, especially for the smaller ones, because we haven't really discovered that many of them yet. The treasure map updates in real time, and China's already halfway to X. Sounds like we got some catching up to do. So let's look at the threat these asteroids could pose by size class, as I promised you a moment ago. So the total near-Earth asteroids estimated to exist for all sizes. This is all just near-Earth asteroids. We believe there's 1 to 2 million NEAs larger than 30 meters. That is the most common sighted modern estimate. Now let's talk about a breakdown by size, population by diameter class. 1 kilometer and larger, like one of those we just found out in the Lagrange system. Uh, and those aren't really considered near-Earth asteroids in terms of threat risk because they're pretty much locked into the Lagrange system, fortunately. So there could be more of those there. Anyway, these are civilization-ending level impacts. If you're a kilometer and larger, the impact will be horrendous. Estimated total, about 1,000 of them. About 1,000 things that get out there that flying around near Earth that could end our civilization. How many have we discovered? Well, we hope and think better than 95%. Let's do hope. We got these being tracked. The population is considered essentially complete in terms of discoveries. But then it gets more interesting with the smaller ones. The 140 meter and larger ones, these are the regional impactors, possibly taking out a continent or a large region on one. This is a size class that Congress specifically asked NASA to find 90% of. It's estimated there's a total of 25,000 of these. What have we discovered so far? 10,500 to 11,000. Survey completeness only 40 to 45%, which means we're only halfway to finding these. And those are a big concern. I mean, if you could take out the United States with one of these, we're maybe United States and Canada too, or Mexico. I don't know. These could be large, or they could take out like the Northeast, the Southwest, the Southeast, Northwest, whatever, middle part of the country. Just depending on a lot of factors. So let's talk about this 30 to 100 meter size class because these are city killers. This would be a big interest too, like the Tunguska class. Yeah, when the Tunguska event occurred in Siberia in 1908, it flattened trees for a long way out for an area that, if it were overlaid over Washington, D.C., would extend outside the Beltway. That would be horrendous. Well, I don't know. Some of us might consider that urban renewal. If it were Washington, D.C. But anyway, we're starting to get into the harder to find class, 30 to 100 meters, Tunguska city killers. It's estimated that there's like 1 to 2 million of these. And so far, we've only found a few percent. These are the NEAs responsible, like I said, for that Tunguska level event, and they're claiming they happen about every 1,000 years. I think the frequency is a lot more than that. I think they're being very conservative on these frequencies of these events. So, yeah, we'll have to talk about that in maybe another video. But these are serious. I mean, if you had an asteroid hit today in the same place, especially if it maybe hit Moscow, it could trigger Russia's dead hand system, which could launch all the nukes they have. And if it happened between India and Pakistan, it could be mistaken for a nuclear blast and could launch a war there anywhere. So we're not just talking about the event itself. It could be mistaken for a nuclear event if you're not tracking it, if you don't know it's coming. If you know it's coming, oh, yeah, you can say it's this, and it would be a lot safer. But we don't know that many of them yet. We've only found a few percent, which is scary. Now let's talk about this 10 meter, the class from like 10 to 30 meters. These are still big things. This is the Chelyabinsk class. So it's thought there's 20 to 30 million of these. And so far, how many have we discovered? Less than 1%. Yikes! These can be very damaging. And that we found less than 1%, now that is very concerning. So let's start with the Chelyabinsk event, the one that this class is kind of named after. The Chelyabinsk meteor airburst happened on 15 February 2013, and it injured about almost 1,500 people. The official figure reported by the Russian authorities and later confirmed by scientific reviews is about 1,491 injuries, and maybe some weren't reported. So almost all of these were caused by flying glass after the shock wave shattered windows. So there were no deaths. like I said, 1,491 documented cases of people being injured. The vast majority suffered cuts, lacerations, and eye injuries. A smaller number, though, had blast wave trauma or hearing damage. It was loud. Why so many injuries? When the meteor exploded, it was 400 to 500 kilotons of TNT equivalent. This is like one of our, strategic nuclear weapons. Got to consider the Hiroshima and Nagasaki were only 15 kilotons. So this is much larger than that. It was way up in the atmosphere, fortunately, but still, it had uh, some major effects. People rushed to the windows after seeing the bright flash. They don't know what's going on. And unfortunately, 2 minutes later, the shockwave arrived and shattered glass across the city. And that's what caused most of the injuries. I mean, they're out looking at they get glass in their eyes. Uh, so let's look what happened in Arizona. Now, in Arizona, we had the meteor crater, which is kind of in the class just above the Chelabinsk class, but pretty close. So the Barringer meteor crater impact, uh, it's pretty much like I said, it's close to in this class range. It's real close because it was thought to be a 50-meter iron asteroid striking what is now northern Arizona about 50,000 years ago. Of course, this could be also in the lower end of the Tunguska class, but this one being iron, it struck the ground like Tunguska, which exploded in the air. So, though the crater is only actually 1.2 kilometers across, and I've seen it from the air flying over. You can see it from an airplane. It's that large. The actual damage zone from the impact was far larger than that. So let's talk about radius of significant damage. The immediate blast destruction zone, or the immediate blast was about 8 to 10 miles or 13 to 16 kilometers, whichever system you pay attention to. Uh, this is the region where everything was flattened or obliterated. Yeah, 8 to 10 miles, everything flattened, obliterated. Trees and animals in that zone ceased to exist. Shock wave pressures reached tens of kilopascals to just greater than 1 bar. The latest estimate comes from energy release. It's thought to be 10 to 20 megatons. 10 to 20 megatons. Large, this is in the class range. I think 15 megatons was the largest nuke device the United States Castle Bravo ever detonated. So this is equivalent to 50 to 60 meter iron bolide at 12 to 20 kilometers per second. So that's what you get with that. So if you look at scaling this stuff, the severe thermal radiation from this blast went out 20 to 25 miles. So that would be reaching almost to me. Not quite, but within this radius, there were firestorms or widespread ignition of vegetation. It was very likely. Exposed animals would have suffered lethal burns. The flash would have been brighter than the sun. This matches thermal flux model for a 10 to 20 megaton ground impact, or Castle Bravo. So if you think about that, 20 to 25 miles, most animals in that region ceased to exist. Now, if there had been houses with windows at the time, which there weren't, at least not as far as we know, glass windows in this area 50,000 years ago, uh, you would have had a moderate damage zone of window breaking out to 40 to 50 miles or 65 to 80 kilometer radius for those down under, my friends in Europe. The pressure ray would have been strong enough to break windows and indeed cause some animals that were in that zone to cease to exist if they were caught in the open. So you could have significant damage out to 50 miles away. Now we're talking stuff that, yeah, well, I'd have felt it here where I'm at had that happened today. Let's hope not, because I'm not that far from meteor crater. Significant overpressure shock waves, equivalent to large volcanic explosions, large ones. So regional dust and ejecta fallout, that would have occurred over 60 to 100 miles or 100 to 160-kilometer radius. Yeah, I'm definitely well within that zone. I'm definitely well within the zone where I'm at here. Uh, Light debris and spherules may have fallen out over most of northern Arizona. Yeah, there'd be some right here. A darkened sky or short-term cooling occurred regionally. No global effects. This was a regional, not global event. But I'm just putting these things in perspective for you. And to think that we've only found a few percent of those and less than 1% of Chelyabinsk size impactors suggests we have a lot of work to do. And this is why it's important. But it's far better if we could turn these into useful materials than stuff hitting us. You know, we could take some of the mining off the surface of Earth and bring some of these things back to here to use here. We can bring materials to Earth. We can bring energy to Earth. Or we could use these things in space. So now let's look at opportunity. Let's look at the opportunities these asteroids and later comets could provide. And I'm going to look at this in terms of space colonies. So, because it's a topic that I love, and this, I think can be a very fruitful use of these materials. Although everything wouldn't be turned into space colonies, you would use some of these materials for other things if you have large-scale space manufacturing. And see, that's what we do not have today. We do not yet today have the ability to go into space, mine space, and process it in space to build things. But we're on the cusp of it. Now with the space transportation costs dropping, as we start to launch a Starship, SpaceX Starship, and even to some degree with Blue Origin's New Glenn rocket, we can see things happen we've never seen before. We're on the cusp of these days happening. So if all the NEAs, near-Earth asteroids, were repurposed into Bernal sphere space colony style habitats with an internal diameter of about 1.1 miles, you could build 10 million Bernal spheres if you were using a 4-meter thick shell, which is very conservative. You only need about 2 meters to stop secondary particles from cosmic rays. So you might just double this number, but let's stick with the 10 million Bernal spheres because that number also allows you to use half the material for something else, basically. So we'll stick with that number. So we'll say 10 million Bernal spheres. And these would be housing about 10,000 people each. And a Bernal sphere that size, you might actually even get 20 to 30,000 people in them with ease. But we'll stick with 10,000 for now because that can support 100 billion people. 100 billion people. More than 10 times what we have here on Earth, just from those little rocks floating around and near Earth out in space. But that's only about 2/10. Now, the total surface area, the inside of these Bernal spheres, would only be about 2/10 of Earth's surface. But still, that's 2.5 times the combined area of North and South America. Or the moon, which are each only registering in at about 8% of the surface area of Earth. So you have to remember, 70% of Earth is water, and the land is mostly deserts, tundra, and mountains, swamps, or in the cases of Antarctica and Greenland, covered with massive ice sheets. So using main belt asteroids, you could build main belt. Now let's go out to the main belt. We're going to step out a little bit here. You could build 30 billion Bernal spheres. Again, assuming 4-meter thick shells. As I mentioned earlier, you could double this number. But with this number, you could house 300 trillion people. You could build about 590 times the surface area of Earth. Really, you could probably get about 1,000 times the surface area of Earth if you use most of that material for Bernal spheres, but we'll stick with that. 590 times housing, building 30 billion Bernal spheres to house 30 trillion people. That's 300 trillion people. That's very interesting. So, like I said, with 2-meter shells, you could build over 1,000 times the surface area of Earth. Anyway, so for your dark fortress galactic civilization scenarios. The NEAs are just the appetizer. The main belt is an actual buffet, but the Kuiper belt and Oort cloud, man, that's some serious dessert. So you get 10 times that with the moons of outer planets, too, what I just mentioned for the main belt asteroids. But let's just move on. So then when it comes to the Kuiper belt and Oort cloud, you would be able to build 1.78 trillion Bernosphere dark fortress habitats hiding inside of comets, replicating the surface area of Earth 35,700 times over. This could provide home for at least 18.2 quintillion people. 2.22, we can get a lot of twos in this. Where's R2D2 at? 2.22 billion times the population of Earth today, just in comets alone. You see, there's some stuff out there that's interesting. And as you expand out to the edge of the Oort clouds, you're almost halfway the nearest star, because the Oort cloud has a radius from the sun of about 2 light years. So, and the closest star is about 4 light years away. So, at that point, humans could just hop over to the adjacent star's Oort cloud. I mean, they're almost brushing up on each other and start working their way down toward that star. This frontier is endless. We could literally pave the road to the stars with those little rocks near Earth if China doesn't put up a roadblock. Now back to China's secret land grab mission in the sky. So the real prize isn't science. This is what we're going to get to. Oh, so many people say, oh, NASA, science, science, science. Forget science. There's better things to do in space, believe it or not. Proving that Kamo-Leva is a lunar shard would be cool. But the true jackpot is this. If it is moon debris, China just proved you can harvest lunar material without having to leave Earth orbit. Well, at least very high Earth orbit. You wouldn't have to climb up and down the gravity well of the moon, which saves a lot of energy. Yeah, again, that delta V I've been talking about. But from there, build a fuel depot, refuel spacecraft in deep space, and head for Mars, main belt asteroids, to our Lagrange points, and do it at a fraction of NASA's cost. Oh, see what China could set up? Their highway to paving the road to the stars. The risk, if the West doesn't get up there soon, is not only a loss of enormous resources and wealth, but access to Nile. Yes, and perhaps the continuity of Western civilization. Yes, indeed. Our very survival is at risk, not just from these space resources that can hit us, and instead of us putting them in a bank account, but from a rival such as China. Remember, China's missile forces are set up around China today for anti-access aerial denial, A2AD, as they call it. Not only could China potentially drop an asteroid on somebody they don't like one of those regional size classes, but they could use a coal gun known as a mass driver set up on either the moon or one of these large quasi-moons or Lagrange point asteroids to deny any nation on Earth access to space. I mean, they could shoot down everything as it launches. If that nation is not already up there setting things up. See, not only though but they could raster fire projectiles. I mean, as you take that coal gun like a machine gun and just raster fire projectiles from these bodies like rods of God, wiping out our cities and facilities without risk of radiation or nuclear winter. from these high grounds, China could own Earth and all cislunar space, which is all the space being in orbits around the moon and Earth. So this can be serious. That's why we can't afford, by any means, it's not just about money, it's about our survival. We can't afford to let any other one nation be up there by themselves to do whatever they want. So, here's my closing thoughts. In 1849, people dropped everything and rushed to California with pans and pickaxes. In 2025, China dropped everything and rushed to a mini-moon with a sample return capsule and made sure the whole nation knows its name in Mandarin. And Americans never heard of it. Wow. Today's 49ers don't wear cowboy hats. They wear CNSA patches. That's China National Space Agency. And the gold isn't in a river. It's drifting 15 million kilometers away, waiting for whoever gets there first. Tick tock, America. Call to action. The next space race isn't in 2030. It's happening right now. Follow Tianwen's 2 progress. Track Laiwa, that's the Chinese pronunciation, closing in. And watch China turn a forgotten quasi-moon into the biggest power move of the decade. Because in this gold rush, the one who will rise first doesn't just pan for nuggets. They claim a whole mountain in space. We can't afford not to go forth and mine ourselves. So, if you watched this far, tell me in the comments below that you don't want to see China roadblock the stars. Or say, let's pave the road to the stars and start with those little rocks near Earth. Yeah, tell me one of those two things, and I'll know you watched this to the end, and I'll greatly appreciate it. So, my friends, keep looking up as exciting things are happening in space. I will bring you more of these things here on Galactic Graves. So subscribe, bang the bell, and click all. Okay, so to watch another one of my informative videos, click right here. And I want to say thank you all for watching. I appreciate all you watchers, you viewers. Share my videos. And Greg.